Alright, Space Cadets, let's have a look at what gravity is. So, first we'll define it. Basically, it's a non-contact force. And if you remember what forces are, they're either a push, pull, or twist. It's a non-contact force that pulls between two masses. So from the center of mass. So if we look down here, we'll see we've got mass A, mass B, or mass 1, mass 2, and you can see that the pull is coming from the center of mass. And it acts between all objects. So any two objects in the universe have a gravity pulling between them. There are two factors that affect it, and that is distance and mass. So here we're looking at, if we come down the bottom of this calculation, you've got G, which is just the gravitational constant, and what you'll see is that so it's just a number that makes the calculation work. That's enough for now. And you'll see that it's got a minus 11, so it's times 10 to the minus 11, which means it's 0.0 with 11 or 10 zeros, 667. So that means gravity is really weak. If you think of gravity as a strong force, just remember you can defeat gravity with a really weak magnet. Like a weak magnet will pick up metal, and that means that magnet is stronger than gravity. So, and the two things that are affected are the mass of the two objects, that could be yourself and Earth, whatever, and r squared, which is the distance between the two centers squared. So if the mass increases, the force of gravity increases, and that's because the number on top of the fraction becomes larger. So if r equals 1, so if it's 1, and you go from having two masses of 1 to two masses of 10, so you go from having the mass of the two masses combined multiplied is 1 divided by 1, that gives you a force of 1 times g. But if the forces increase and you're looking at a combined force of combined masses of 100, you divide that by 1, well then your gravity is much, much stronger. It's at 100. If the distance between the two objects increases, the force of gravity decreases. So that means you're dividing it by a larger number. So if mass increases, you're multiplying it by you're dividing a much larger number. If the distance increases, you are dividing by a much larger number, and this means the force of gravity decreases. So the force of gravity is weak, but it acts at extreme distances. It's actually the driving force behind the movement of all objects in the universe, and while it's a weak force, the small force acts over a long time, and that builds up, and this is why most things in the universe, when they're traveling at very, very large speeds. Gravity in object pulls towards the center. And what this means is, if you look at our planet here, here's Earth, because all gravity pulls all the objects to the center, all the mass to the center, if you're large enough to have a really big gravity, then you become round. Also, it holds us to the center of the Earth. It pulls us to the center of the Earth, which is why it doesn't matter where you're standing on Earth, your feet always point straight towards the center. And we experience gravity on Earth as weight. So your weight is the amount of force your mass is being pulled to the center of the Earth with. It also gives us orbits, which is pretty cool. So basically, here is the Earth, here's the Earth, and here's the Sun. And what's actually happening is the Earth is falling because of gravity, is being pulled, the gravity is pulling the Earth directly into the Sun. But the Earth was moving so fast past the Sun that its velocity is heading in one direction. It's got a force pulling it this way, and that means it combines. So that and that combine to give you that, and that's why it goes around the Earth, around the Sun in an orbit. The Moon does the same thing for Earth. Alright, I know you'll have questions. Put them in the comments below, and we'll get back to you as soon as we can. Thanks for watching. We'll see you next time. Bye now.